Hi, Mick McQuaid here, welcoming you to day 4 and the last day of the first week, day 4 of 780, ISDE 780, data-driven knowledge discovery. And as we end our first week, we do it with a lab in R. So let's get started. What I've got here on screen is my text editor in one window and R in the other window. And I'm using a plugin. The text editor is called Vim, V-I-M. V as in Victor, I, India, M, Monster. And I'm using a plugin called nvim-r, that's N as in never, VIM-R. And that plugin used to be called Vim-R, but it's recently had its name changed because it became compatible with NeoVim, which is another editor that's similar to Vim. And this plugin allows me to type using my text editor, which is more comfortable for me to type in, and then use a keystroke command to send the commands from this window over to this window in R. So that's how I'm doing it. You are likely to do it in a different way. I urge you to get comfortable using a full-featured text editor to do this kind of stuff. But a lot of beginners start with RStudio, very easy to do, or R console. In fact, a survey of R users I just saw recently showed that R console remained the most popular single way to interact with R. So R console is just this REPL, this REPL, this read, evaluate, print loop, or read, evaluate, process loop. This is a feature that comes with all kinds of software, from Python to Lisp to JavaScript. You can all sorts of languages come with interpreters that run through a loop like this, where they just evaluate and process and read something from input, evaluate it, and print a result, and then are ready for the next iteration. So that's what I'm doing here, and that's what the lab asks us to do, is to use a read, evaluate, print loop, and go through some very simple things. Okay, so the basic commands, so we start with the basic commands in R. And this is a little bit different, by the way, than the basic commands in R as given by the tutorial we did the other day from another book. So in this case, the very first thing that we're going to do is create a typing error. Let's see, so we're going to create a vector. Our first task is to create the vector x, and so I'm going to send this over here, and now I can say x. Something is wrong here. So I can say x, and if I say x, it's just going to spit back the vector at me. And I can make x be another vector. Oh, and by the way, the textbook reminds us that we can use the equal sign, the single equal sign, as an assignment operator. I always use the left-facing arrow. We can also use a right-facing arrow, as we learned the other day. But I always just use the left-facing arrow, except in function arguments. Function arguments, you have to use the equal sign, pretty much. Under certain circumstances, you can get away with using the left-facing arrow, but not advisable unless you're using R so much that you just know a lot of the rules off the top of your head. Okay, so now we might want to investigate the properties of x. So its length now is 3 because we changed it. Its length previously was 4. Oh, I'm sorry, I forgot to make y. So let me make y here. Y is going to be 143. Y is now 143, and the length of y is 3, as is the length of x. And so I can add x and y together, and I get 1 plus 1 and 6 plus 4 and 2 plus 3. So I get a vector of the same length with the matching components added together. We can say ls to look at a list of objects that we have, and the objects that we have. Oh, so we have some other objects here because I have not gotten rid of some other objects on my workspace. And we can delete any that we don't want. As a matter of fact, we can get, so I can, for example, say rmxy. And now I can, if I say ls, I would get character 0, except that I've got these other two things laying around. So what I could do is remove everything. So now I'm passing to the function the function rm, I'm passing a list of all the objects that were named by ls. So having done that, and now if I say ls, I get character 0. Okay, now there's a matrix function, and we can get help for the matrix function, except I think my help is not working, so let's see what happens here. Yeah, my help is not working. So you can get help. I can run this in a separate console and get help. There's something wrong with the way that the newest version of this plugin is working with my editor. Ordinarily, help opens in another window of the editor, and I've noticed the last couple of days it's not working. So that's the problem when you use a lot of softwares, and it gets updated very frequently. There are often little issues. So, but I could here. Let me just show you what I might do. If you do get into that situation, you can just open up another copy of R. So let me just open up a copy of R here. And if I say ? Matrix here, another window pops up, of course, off the screen with the information desired about the matrix function. So get rid of all of that. I need that. Okay, so let's let X now be a matrix, and the data for the matrix, which is by default first thing, so I don't really have to say this, but I'm going to. The data is the numerals 1, 2, 3, and 4, and the number of rows will be 2, and the number of columns will be 2. So now I feel like that should be in rows and in calls, but, and do I have the right number of parentheses there? Well, we'll see in a second. And now I'll say X. And yes, indeed. And notice that it filled up the rows before it filled up the columns. That's not right. I filled up the columns before I filled up the rows is what I should have said. Okay, and then we see that we can do exactly the same thing by saying because these are the first 3 arguments that are expected. And I could fill up the rows if I wish. I could fill up the rows before I fill up the columns by adding the parameter by row equals t. And now we get what to me is more intuitive, filling up the rows before the columns. Okay, and now we can also do some things with X, like find the square root. What is the square root of a matrix? Well, indeed, it is the square roots of the items in the matrix. I'm going to say, I don't know if this is going to work. Options digits equals 3. Well, it seems to be legitimate. Ah, it does work. Okay, excellent. Okay, so x squared, what is x squared? and it is the expected 1, 4, 9, and 16. Okay, I can generate, so now I want x to be a vector of random normal variables. Who would have thought we might want that? And if you ask for help about this, about R norm, you will find that it is one of a very large family of very, very useful functions. And see, there's a whole bunch of stuff there. And as I mentioned before, the little number in square brackets is an index of the item that's next to it. So this is the first item, the 10th item, the 19th item, the 28th, the 37th, and the 46th item. So I said R norm 50, so that must mean there are 47, 48, 49, 50. There are 50 numerals in this x vector now. And I can also check out the length of x. There are also other things I can do to describe x. For example, I can ask what the type of x is. Oops. And I can ask the class of x. These are not in the book. I'm just doing them. Okay, and then let's say y gets x plus R norm 50 with mean 50 and standard deviation 0.1. Okay, and I don't know why. Oh, I see. The reason why is because I'm then going to ask for the correlation matrix. So hopefully this is something that you've encountered before. A correlation matrix will tell us how what the linear relationship is between x and y. And what a great relationship x and y have. Their correlation, excuse me, not the correlation matrix, the correlation coefficient of x and y is almost 1. And 1 is the most correlated. If x and y were identical, they would be, the correlation would be 1. And the textbook tells us that R norm creates standard normal random variables with a mean of 0 and a standard deviation of 1, but we're able to do whatever we want. And let's just take a look at y, because although x and y are perfectly correlated, which is to say that if x is large, y is large. See how x and y, although they're highly correlated, they are different. This is just telling us the linear relationship between x and y. And we could see that graphically too if we just plot x and y. This also is not in the textbook, but I think it's quite worth doing. So if we plot x and y, and of course my window is the wrong size here. So x has mean 0 and a standard deviation of 1 by default. That's what a random normal variable has by default. But we gave y a mean of 50 and a standard deviation of 0.1. And in both cases, we said, hey, these guys are normally distributed, and that's what's caused there to be a kind of a bit of a clump of them toward the center and fewer of them toward the edges. The fact that they're from the same distribution is what's making them be so highly correlated. Just take that away for a second and see what. Okay, now let's say I want to generate random numbers. I can set a seed. I can set a seed of 1303, and now a random number generator is going to generate the same set of random numbers over and over again, which is a little counterintuitive. Okay, so I've got this set of random numbers here. And we use it, we can use it so we can reproduce somebody else's results. So sometimes we want what appear to be random numbers. I suppose we would call them pseudo-random numbers. but we want to be able to control what they are. Oops. Okay, so now I'm going to set a seed of 3, and I'm going to say y gets, y gets random normal 100. Okay, so here's the seed of 3, and here's my new y. And the variance of y, what is the variance of y? Well, what is the first standard deviation? Maybe you should guess this before we. So we just told you what the default standard deviation is. Oh, and we also want to know the mean of y. So this sample varied a lot. So we generated. So the true variance here is 1, and the true mean is 0. So we left the defaults in place, and we generated a sample from that population, and the sample mean and the sample standard deviation differ, or sample variance rather, differ from the true mean and the true variance. So that's kind of an interesting thing to know. And then we also want to know the standard deviation, which guess what that is? We could just say SD, but for some reason the book wants us to say, oh, I see, the book wants us to know that the standard deviation is going to be the same no matter how we calculate it. And it is. Yay. Okay, let's create a x vector of 100, of length 100, and a y vector of length 100. And then we're going to plot x by y. And here's the plot. So we've created two vectors, two random vectors, normally distributed, and we've plotted them. And now we can label the plot. So we're going to create another version of this plot. And in this case, we're going to say xlab for xlabel. Xlab, this is x-axis, and ylab will say this is y-axis, and main, oops, not mean, main, the main heading will be plot x versus y. Okay. So we now have the same plot, except it now has a title, and it has an x-axis label and a y-axis label. Exactly the same thing. Okay, and we may want to save the output. So let us say we're going to save something as PDF. Now there are actually several better ways of saving than what are shown in the tutorial. I'm going to just do this tutorial because that's what seems to be what's called for. But we might want to do this a little bit differently. Call equals green, and this is not a good green. This is just going to be some bright green. Okay, so I'm going to say dev off. That's going to stop sending output to the PDF. Okay, so I create the PDF, I send a plot to it, then I say dev off. And if I can find that, let's see. here it is. I've opened it in another window in a previewer. And notice now I'm opening it not in R, I'm opening it in another program. And so consequently, the aspect ratio of it is fixed. The aspect ratio of it was fixed when it left R. So no matter how much I resize it, I'm still going to have the same output ratio for what that's worth, which ain't much. Okay, now let's see. Let's make X a sequence of numerals from 1 to 10. I should probably get in the habit of using the word scalar to refer to integers, or to numerals, I should say, because we're dealing so much with vectors. So X is a vector of scalars. Did I do that right? Yeah, 1 to 10. I could also have done it X gets 1 colon 10, and I get the same result. Now I could have X be a sequence of minus pi, and length gets 50. What do you suppose will be the result of this? Oh, I spelled sequence wrong. So the result will be an error. Okay, now what do you suppose is the error of this? It's going to be a repetition. Well, let's just look at it. Our starting value is minus pi, or an approximation to pi, and our ending value is an approximation to positive pi. Oh, by the way, I use a thing in here called colorize, so all of the negative values here are a slightly different color than the positive values. Are there more values here? No, that's it. Okay, and as we've seen before, we have these indexes next to them. So this is a sequence. The starting element of the sequence is minus pi, and then we just repeat values, in this case evenly spaced, until we get to pi. Okay, now it's time for more graphics. This is really a hodgepodge. I'm not clear on how this is working toward our homework assignment. So I guess we've had, okay, so we've got y is equal to x, and then f is outer, what is this? F gets outer x, y function x, y cosine y. And here I said we were never going to use cosine. 1 plus x squared. Well, that's a familiar concept, actually. And now we will do a contour plot of x, y, and f. So this plot is going to have 3 dimensions to it, the x, y, and f, and the contours are showing us the values of f. So all values of f are equal along one of these lines. And now let's alter this a little bit. I'm going to say contour x, y, f, and number of levels I'm going to make larger than the default. N levels is equal to 45, and add equals true. And so it's a little bit harder to read, but a little bit more harder to read the numerals, but easier to read the lines, I guess I would say. And now we're going to add another function here, and this is going to be let's see, f transposed. So f minus the transpose of f divided by 2 for whatever reason. Okay, so we now have that function. And now we're going to do contour plot with FA instead. The number of levels will be 15, and we're going to take out this. And we get another incredibly interesting shape. And now we can do an image plot, which is like a contour plot, except using color coding. So what are we going to do? If FA, let's say image equals y, xy, and FA. And that certainly looks more interesting. And we can control the plot. Let's make it perspective. Okay, so here we get a wireframe. And we can control how the perspective looks by changing some of the angles. So we'll change theta. I assume that theta was not 30 by default. It's probably 0 by default. And we can also change the angle phi, which is going to be the elevation, I suppose. It's not too interesting. Let's try phi of 70. See if that's more interesting. Phi of 40. Oops, what happened? Oh, okay, I guess I just wasn't looking, so I didn't see the difference. Okay, then there's a long section here on indexing data. So let's let A be a matrix of the numbers 1 through 16. And we're going to do it in 4 rows and 4 columns. I'm going to take this off. And then let's look at A. And there it is, numbers 1 through 16. Now if we say A 2, 3, we're going to get what will be the result of this. See, if I were going to give you a test, I could ask you things like this to test your knowledge of R. Okay, and here's a case where we have to use the combine or concatenate function. And I usually make a mistake when I'm doing this kind of stuff. For some reason that came out all right, but usually I need, this is one of the reasons I need a full-featured text editor, because I need it to do a matching parentheses or matching delimiters in general, because otherwise I don't get it. Okay, so here we got, let's see, row 1 and row 3. And column 2 and column 4. So that's how we got 5, 7, 13, and 15. Okay, and then we can do other gyrations here. If we do these things contiguously, I think I mentioned this before, that if we choose our indices contiguously, we don't need to use the concatenate feature. And we can just give one and not the other. We can just say rows in this case. So I want rows 1 and 2. It's just going to give me all columns in rows 1 and 2. And I can do the same thing with columns. So I'll just put the comma in the other place here. Now I get columns 1 and 2. And I can just get column 1. And I can use a negative sign. So we've already done that, but let's do it again. So I'm going to say I want everything but but rows 1 and 3. Oops, I want that, but I don't want those. Okay, so that gave me everything except columns 1 and 3. And I can also say I want everything except columns 1 and 3, and everything except rows 1, 3, and 4. I don't want much. And all I get is 6 and 8. Okay, so what is the dimension? What are the dimensions of this matrix? The dim function will tell us the dimensions. Okay, so enough of indexing, and now we're on to loading data. So we've already actually loaded this data, but let's do it again. The data in this case is the auto data, and it's part of the ISLR library. So I've previously loaded it. If you recall, I just Googled ISLR and auto data, and it put me on I think the second or third hit was the ISLR web page. And one of the items featured prominently was the auto data file. Now, I don't particularly like the auto data file. In fact, I altered it. Let me just bring it up on the screen here. I altered it a little bit to make it a tab separated values file. And I like it better the way that I altered it than the original file. The original file, I don't think this is the original file. I think this is the way I altered it. And it has, the way I did it, it has a tab between each. If you download the original file, you'll find it has tabs. It has some tabs between some of the columns, and some columns have more tabs than others. And the final column doesn't have any quotation marks around it. So if you try to change, it's kind of a mess the way that it's set up. But auto.csv is there also. And that's what they actually do. So they suggest that you read the table auto data and fix it, which I'm not going to do because it's just really boring. Instead, I'm going to just go right ahead to reading the thing that I want, which is the CSV file. So I assume that you've downloaded the CSV file. So you have that file, and you have it someplace where R can tell where it is. So, and the way that you, by the way, let's go back before I do this. I'm not going to finish that. First I'm going to say GetWD and setWD. So GetWD tells me what my current folder is. If I don't like the current folder I'm in, setWD can be used to change it. I can change it to users mjmics 780 data driven blah. I don't have such a directory, but if I did, I could give that instead. And once I've changed, and I could change it then to whatever directory I've downloaded auto.csv to, or simply move auto.csv from my downloads folder, which is what I did, into my lecture folder where I'm working. I personally find it very uncomfortable to work in the same folder where I've downloaded stuff. That leads to overwriting files. So I like to have a different work file than a file where a different work directory than a download directory. Okay, so where were we? Oh yeah, we're going to do this. So I'm going to read CSV, and this is, by the way, an example of object orientation. So there's this read function that has several different methods in it. One of the methods is CSV, and it has a header. So I'm going to say header equals true, and it has NA strings, and the NA strings are question marks. So anytime that data was not available, somebody put a question mark in there. So I'm going to read the auto data in that way. And I can do a lot of things to figure out what's going on in there. So one thing, for example, I'm not going to do the fix thing. Fix brings up a window that looks like a spreadsheet, and it's just kind of a waste of time as far as I'm concerned. But feel free to do fix auto too if you prefer. Okay, so this tells us that we have 397 rows. So n is equal to 397, and we have 9 columns, so p is equal to 9, although actually we're only going to probably use p equal to numbers less than 7. Yeah, probably p is going to be less than 7, the number of predictor variables, because one of the columns is the name, and we're obviously not going to use that as a predictor. And one of the columns never seems to get used, so it doesn't matter. So we can use a maximum of 7 columns. Oh yeah, right, because one of the columns is going to be y, one of the columns is going to be the output, so we want to predict the some output based on some input. So of the 8 numerical columns we have, we're only going to use 7 of them. Okay, and we can pick up. I'm just going to get this off the screen here. We can look at a portion of it. So I'm going to look at auto rows 1 through 4 and all the columns in rows 1 through 4. And that's what we've got in rows 1 through 4. We've got a Chevy Malibu, a Buick Skylark, a Plymouth Satellite, and an AMC Rebel. This, I think, is an old data set. I don't think AMC exists, right? And I don't think AMC has existed for a long time. So anyway, now I can omit. We did this also yesterday. So I'm going to say auto. This auto object is now going to get the result of saying NA omit auto. So this is going to kill off 5 rows. It's going to kill off the 5 rows that have question marks in them. So now if I say dim auto, I get that it's 392 rows long. Names, that's what I was trying to think of before. Names, that's going to give me the names of the columns. Let's see, some additional graphical and numerical summaries. So I can plot cylinders times miles per gallon. Oh, but I didn't attach, did I? Oh, and that's sort of a lesson here. So I'm supposed to get that error because I didn't attach. So I can do one of 2 things. I can either do the really annoying thing, which is this. I can say auto $ cylinders and auto $ miles per gallon, and that will work. Let's see if I can find my plot window. So there's my plot window. I like to shrink that a tiny bit. The other thing that I can do is say attach auto. So I may have declared lots of data sets. That's the point here. And so I may want to only work with one data set. Also, a lot of data sets have the same or similar names for the columns. So I only want to be visible to me, I only want the names of the columns of the data set that I'm actively working with. So I can attach and detach data sets without killing them off in the R session. By the way, of course, I'm not killing off the file that I read these from. Nothing that I do in R is going to affect an external file unless I try to do that explicitly. So this attach and detach or simply make it possible for me to do something like this without an error. Okay, and then here's where I'm going to make cylinders a factor. Cylinders gets as factor cylinders. Okay, now I've been going on for an exceptionally long time, so I think what I'm going to do is take a quick break here. Just taking a look at some of these other... Oh no, there are very few things left to do here, so this is a really short tutorial. I may have to supplement this with something else because there's so little that we do here. So basically we have some plots and some histograms and a few graphics here, and that's about all that's left to do. So let's do that. So I've made cylinders be a factor, so that signifies I'm treating it as a categorical variable. And now let's see what happens when I plot cylinders by miles per gallon. Now take a look at this plot over here and notice that it's got 8 cylinder values listed, even though only a few of these are actually used. So now what I'm going to do is plot with it as a factor, and instead I get a set of box plots. These are called box and whiskers plots. And this happens because of the categorical nature of cylinders. And I can also color them. And I'll give them the worst color. Later on we'll learn better colors. These are like the dopiest possible colors that we do at the beginning. And you may think that I'm only saying that they're dopey because they're ugly, but there have actually been a lot of studies of statistical graphics that show that people are better able to answer questions about what's going on in the graphic if you do better colors. So it's worthwhile to advance our understanding of colors. Okay, and I'm just going through the various junky things that that the textbook is going through here. You should be able to do this without my thrilling video. Oops, so I already added that one. Now this is just to add labels. Okay, so I add the X label of cylinders and the Y label of miles per gallon instead of X and Y. Okay, and I can do histograms. So I'll do a histogram of miles per gallon. Histogram, by the way, is a word that has a lot of different meanings in statistics. And it looks, the kind of histogram that we're doing here is just, I want you to bear in mind that this is one way of thinking about it. By the way, I said color equals 2, so evidently color number 2 is the same thing as red. Now I'm making it a little bit finer, the number of, wait a second, did I make it finer or not? Oh, I made a mistake here. There we go, so I made it in finer detail. Okay, and then pairs, which we've looked at already. It's going to give us a scatter plot matrix. There are other commands for doing this called SPLM, S-P-L-O-M, for scatter plot matrix. And you have to enlarge this to make any sense out of it. So you can't really see what's going on here. And if I enlarge it, of course, it goes off the screen. But what happens is that if you can enlarge it so that it fits your screen, you can get a lot more out of it. And we can restrict our scatter plot matrix to just the things that we think make sense. So I'm going to restrict it to miles per gallon plus displacement plus horsepower. I'm gonna limit it a bit more than the textbook does. I'm gonna limit it like that. Okay, so it fits in the window a little bit better. Then there's an identify function, which is buggy on my copy of R, so I'm not going to do it. Let's see. It actually locks up my copy of R, and I'm going to have to check and see if I get if it's, and I don't know if the problem is with my copy of R, because I am able to do it. Actually, I know it's not my copy of R because I can do it over here. I can do it in this console, but I don't have the data loaded in there. But there's some interaction between my plugin and R that prevents it from working. So I'm not going to do identify. I'm just going to skip that and go straight to summary. Or no, actually, I can't remember. Maybe, you know what? Maybe identify does lock up my other copy of R. I don't remember now. I'll look it over because it is a useful function if it works. Okay, and then that's the last thing. Oh, there's summary mile per gallon. That's the last thing in the lab. So I'm going to close this video here, and that's the only video I plan to do for today. But I'm going to talk to you and see about possibly doing some more R commands on video to help you prepare for the homework assignment for tonight. So thank you for your attention during the first week, and I look forward to continued 4 more weeks.